Okay, video number 2. We're testing this capacitor here. I got this from a pair of radio cells. Oh, a year and a half ago or more. I noticed this particular case here. I had my novel idea using these parts here to hold it down without disturbing it too much. This particular piece of metal here, it's got as you can see, bolts. I took leg bolts, heat them up, and put a piece, bent them over, put it through the hole, drop down through this case, and hold it steady. Okay. Is that one of them? No, I think so. Yeah. So that's held down like that. And then on top, I built this section for it. Very reactive. Yeah, it's connected to here, to the meter. And we've got the meter turned off. Turn it on. Boom. Through 30 volts. 0, 0, 0. Okay, give it a charge. Go to continuity testing, which puts 9 volts in it. OL. Mr. Testing continuity and circuits. A 9-volt battery in there. So. Alright, so I do that and then go to 30 volts again. Okay. That tells me it's a little more complex. What's the old, oops. That's weird. Volts again. Now, when I got this, both ends were put together with a cable, actually. Could be self-reactive, just need a kick in the ass, you know. Okay, so it might need a little extra power, so we'll do that with our little power supply again. So, disconnect this. Connect the power supply and check for dimness. Like, very simple, primitive process, but it works. Okay. Yeah, it does. Yeah. Oh, here we are, still connected. Okay, so we take our little power supply again. Oh my goodness, Mr. Spock. Put 114 volts DC in it. Plug it in, and we plugged it in. Take our wire. No pulling your wire. Get on the floor, will you? Thank you. And then we hook positive and negative. And where's the other one? Oh, right, yeah. This is negative, okay. There we go. And we'll see if there's dimming of those LEDs. Okay. It is connected and no dimming of LEDs. Fine. Right. And then what we're going to do is just let that sit for a second or two. It's still plugged in. Yeah. Oh, how sweet it is. Yes. Yeah, different view from over here, huh? Ooh. A lot of capacitors. Okay, so what we're gonna do, children, kids, or hobbits, or animals, we're gonna disconnect and take a reading. I don't know how to do that without doing this, but anyway, we'll disconnect. 1, 2. So much work. Oh, where's our meter go to? This is a very large capacitor, as you may know as well. Negative or positive or negative. Turn the meter on. 30 volts DC. Let's see what we get here, huh? Ooh, nothing there. So I haven't connected it yet, so let's do that. So, connecting. So, let's see. Connected. 30 volts. Oh, good, okay. Drops fast, as you can quite see. Which I can see if it reverses, which indicated something else in there besides a capacitor, like barium titanate. Will it reverse? 0, 0, 0. Don't know. Doesn't look like it. No, no, that's a very active capacitor. Have no idea where it's 100,000 volts rated for, so it would at least need several hundred DC volts in there. These are 50,000 each. That's about 50,000 too, I think. 100,000. So that was capacitor testing, all good. All waiting for a big suck of energy. Turn this little thing off. Disconnect. And remember, if you're goofing around with the stuff, always short it out, okay? Don't do what I do. Short it out. Then take measurements, okay? It helps. You don't get zapped across the room. Right, right. So we disconnect this. And I'll show you briefly, make sure everything's unplugged. I guess put our balls back on the capacitor, right? You never know. There we go. The balls. Okay, now, even with electrostatics, be careful. You can get really burned fast with one of those things. That's a baby one. I want to make a big one. At least a 2-foot diameter ball like it did before. Picture of George Hathaway standing by it as well. The government came down. Okay, everything's unplugged. Double check. It's going to drive this thing too. Well, where was I with all this nonsensical gibberish talk of mine? We're talking about power supplies. So walk around here. Here's one down here. That's a power system. Put out a real hefty voltage. And we have another one somewhere. Over here. Warning, danger. Ooh. Kilovolts and milliamperes. Oh, kilovolt milliamperes. This power supply. Does that say warning? I think so. Yeah, so you gotta be very careful with this kind of stuff. This came from Berkeley, by the way. Speaking of high voltage stuff. Auction, I think $5. Usually $1,000, something like that or more. A lot of stuff you can get on auctions of universities for hardly anything. Way to go. Where's the scrapyard? Okay, so that's done. These are antenna couplers. So. This is one of my monitoring stations. These guys are AC type 3-phase capacitors, right? Right. Very useful for dynamic energetic situations. Oh God, yes. Anyway, that's the end of that.